Welcome again everyone. In today's video we will discuss and understand a lot of great concepts related to industrial and manufacturing plants. So if you are a chemical engineer, petroleum, system, industrial or mechanical, then I advise you to listen and focus throughout this video. We'll start with a really famous word, which is, as you probably know, process. Now process has a lot of different meanings. It has a different meaning in English, it has a different meaning in engineering in general. But whenever we discuss process in industry, then we mean converting raw material, making them converted to useful product. We have them already. Maybe they are produced from another facility or an industry, we don't know, but we will use them as a feed or input in order to process them and convert them to useful product or output that can be used, maybe can be used as a raw material for another process, can be used for daily life purposes, or even can be used as an indicator in some processes that contain odorless chemicals or colorless chemicals. Real life industrial processes that are really and fundamentally important, used up to now 2023, is refining process. Refining means everything for a country to work, because from refining raw material comes, and then many important products come that represent the heart and the lungs of a certain country. You might say I'm exaggerating, but the products that come from refining include, most of them you know, of course, or probably you know: gasoline, kerosene, diesel, asphalt, lubricating oil, and heating oil. Gasoline is important for car, as you know, transportation. Also kerosene for planes and rockets. Diesel for heavy cars like buses or trucks. Asphalt, which is the road basically that our cars drive through. Lubricating oils, which reduce the friction of a certain car or a bus or a truck. And lastly, heating oils that cool off the residential building. So yeah, when I say it's the heart and the lungs of a country, then there is no any exaggeration, because these are really important products that come from the raw material, which is here in this case crude oil, which our country has a lot of it. So if you heat crude oil in a refining process, which includes basically heating the crude oil and then separating the resulted heat into these very essential and important products to serve our country. As for the company that has already succeeded in producing massive amount of these refined hydrocarbons, then as we all know, the biggest oil producer, Saudi Aramco. What is the next step now? The next step is taking all of these products and then put them into another process. The product, as we know here, product or output, is or are petrochemicals. And this is, by the way, another important process that is used extensively in industry, because it's just the following step. After having these important products from Saudi Aramco mainly, then it will be processed into forming petrochemicals: ethylene, propylene, also, if I remember, xylene, and benzene. We have also toluene. Most likely, when you say petrochemicals, you will refer to ethylene because it's the most commonly produced one, I might say. And also propylene. Example of a very successful company that already also has succeeded in production of petrochemicals extensively is Saudi Arabia Basic Industries Corporation, the hardest word, or as you briefly know it, SABIC. So whatever is produced from Saudi Aramco, for example, it is further processed in SABIC, for example, and then the result is these very important petrochemicals that some of them, by the way, are used as raw materials. as we said here, raw materials. The one that we have maybe from other facilities or already available on nature. For example, ethylene is used in the production of ethyl benzene. Use it with benzene, then you will produce ethyl benzene. And propylene could be involved in hydrogenation process, which results in formation of propane, which is only single bond. Moving on to another key process, fertilization. Especially in Saudi Arabia, as you know, we have this unbearable weather, especially in summer. And with these fertilizing chemicals, we will be able to improve soil fertility, which then helps improve plant development, and then we will have more crops, more yields. So it's efficient and it's important, especially in hot weather like Saudi Arabia, because we have limited space in which our plants grow. So with the fertilization process, you increase the soil fertility, which means you provide food for the plant to grow, and then this plant, of course, will yield in the end, and we will have more and more agricultural sector that will help significantly to cover most of the deserts that we have in Saudi Arabia with greener lands. The company that's responsible for this massive production of these fertilizing chemicals, Saudi Arabia Mining Company, known as Ma'aden. Moving on, we have polymerization process. Such fancy names, filterization, polymerization. And this is responsible for our clothes, for example. We wear a lot of things that are made of polymers. So we have raw material, polymerization, and then the product is polymers. Usually the raw materials are something known as monomers, which is only one single component. Polymers is many of this same components, and it is very important because polymers are responsible for the packaging materials like this, for example, water. Also we have plastic bags, films. The advantage that they are cost effective, durable, which means they last for a long time, and also they are lightweight. They are very, or let's say considerably light, not heavy, and also recyclable. And the fact that they are recyclable is a really, really powerful economic advantage, because it means less using new products, less price, less using energy to produce such products that we will use as raw materials, and it means less wasted materials, because these wasted polymers can be recycled again to be used over and over to make a new polymer, to support some other reactions, and so on. The company responsible for production of these polymers, once again, SABIC, the powerful company for producing petrochemicals and also polymers. But also we have another one, National Industrialization Company, or as we know it, Tasneer. I will conclude now with Speciality Chemicals, which are a product of some certain raw material. When I say specialty chemicals, I mainly refer to very important term, catalysts, because they help speed the reaction. Use it if it is necessary. If the reaction is fast without any addition of catalyst, then don't use it, because it will not be economically advantageous. But they are used whenever we have slow reaction. We have also specialty polymers, are responsible for increasing the strength, durability of certain polymers. So if you produce a certain polymer and you want to strengthen it, for example, then you add this specialty polymer to the process, and it will increase the strength, maybe it will increase the durability, the lasting time of the polymer itself, the one that you produced, and conductivity. We have also electronics, production of semiconductors, the one that is neither conductive nor not conductive, so it's in between. The company responsible for production of specialty chemicals is Saudi International Petrochemical. Of course, because the name of the company is including petrochemicals, so we are expecting also that they produce petrochemicals. And then Saudi International Petrochemical Company, shortcut for SIPCHEM. All of these industrial processes I mentioned are the zero step. And now let's come to the first stage, or as I want to call it, the ninth drug, knowing what is process in details. So a process, regardless of any process we are encountering, it could be physical or chemical. Physical process, no reactions. No reactions at all. No, even one reaction, there is none. But chemical, we have one or more reaction. At least one reaction taken place, then we will call it chemical. If there is none, we will call it physical system or physical plant. Like the refining, it was physical process because we just are separating crude oil by heating it into different refining petroleum products. And you, my friend, as a chemical engineer or someone who will more likely to be involved in industrial processes, should know what is the meaning of physical and chemical, because you are more likely to be asked to design or operate a chemical or a physical plant. And while the idea of producing large quantity of quality product is fascinating, you also have to consider the economic part. You don't want to use raw materials that are expensive to produce something not profitable. You don't want to design or operate something that does not consider the market trend. Like if the market demands us to increase the production rate and the equipment that you are using do not withstand the high production and at the current operating conditions, then there will be a consequence like delaying in the production, or what we call it in engineering or industrial terms, bottlenecking. So bottlenecking happens whenever you have the equipment at the current operating conditions do not withstand the market demand or the asked production rate. Then bottlenecking will happen, backlog will happen, or delaying in the production will result, and this will of course have economic drawback. It will not make the company worthwhile or trustworthy. So you are a very powerful member of your society and country because you get to decide. You get to think and analyze not only the chemicals you are dealing with, but also the impact environmentally, safely, economically. But also we are humans, so we have to have the ability to adapt with the situations. If bottlenecking happens, then you have to de-bottleneck it, which means you have to solve this problem. You have to troubleshoot it in a way that facilitates the production rate and satisfies the market trend or satisfies the company's goal, whatever purpose. I don't know if you notice or not, but I keep fixating on that we should know what is the process, we should know how to make economic, safe, and efficient process, but what are the important things that allow us to decide or to conclude that our process is successful? What factors will you work on in order to increase or decrease the efficiency depending on market trends, for example, or depending on what you want in the first place? And for this we need to introduce process variables, the variables that give us an insightful conclusion of whether or not we are going on a right track. The process variables we are facing could be of two types: extensive and intensive properties. Extensive means when the size is important to the value, when the size contributes to the value itself. But intensive, it means regardless of how big it is, the size, it will not affect the value. That is intensive. An example of extensive property: mass, volume, energy, entropy, as we will see later on, length, surface area. I think that's more than enough. We usually say mass, volume, but I wanted to add more: energy, entropy, length, surface area, also charge. Intensive properties, as I said before, they do not depend on the size. The size is not important, how big it is, like temperature, density, viscosity. We discussed it when we talked about dimensionless number, about Reynolds number. There was a term of viscosity, the dynamic viscosity, and also the kinematic viscosity. All of them are intensive. Boiling and melting point, which makes sense because they are also temperature. And the last thing, specific. Whenever you see specific, even after the specific comes a word that is extensive, like volume, then it will be intensive. Specific volume, specific energy, specific enthalpy, for example. It's a type of energy. Specific entropy, then it will be an intensive one. Because we will divide by either. We will divide this volume. Specific volume means, for example, volume divided by either mass or, here I should add also moles. Or moles. So we will eliminate the size dependency. We will make it only dependent with other terms not related to the size, making it an intensive variable. So the things that I mentioned here: temperature, density, viscosity, boiling and melting point, and also specific, and whatever comes after this specific word, it will be intensive, even if you see an extensive word. The variables that I have written will almost all the time be mentioned in the undergraduate course, maybe except for the charge, maybe. But the others are very, very important for those who will end up working in an industry. Let's talk about them one by one. Briefly, we'll start with mass, volume and density, as we know before from the previous video, and also from our knowledge that density, rho, is equal to mass over volume. Intensive equal to extensive over extensive. But the new thing is when we divide by time. So when we divide here by time, when we say mass over time, and here volume over time, this mass over time is a very important term we are using extensively in industry. It's mass flow rate, and V over T is volume flow rate or volumetric flow rate. Rate because we have time, volumetric because we have volume. Here once again rate because we have time, and mass is the same. This M over T, we call it M, and here we put dot in the top. The same thing here, V, and here in the top we will put a dot. This dot represents a flow rate. Sometimes it could be referred with another symbol depending on the book you are reading from, but the book that I'm reading from is Elementary Principles of Chemical Processes, and it uses M, V and every other symbol with a dot that represents or that gives us the indication that we have a rate, we have a flow rate. It will give you H dot, which is the enthalpy type of energy. So whenever you see dot, you know that it is a flow rate. When we talk about now density could be density of solid, density of liquid, the three states, density of gas. Solid and liquids, they are a weak function of temperature. Density does not depend on the pressure for liquid and for solids only. So also weak function of pressure. I might specify a little bit about liquid. If we are talking about incompressible liquid, the liquid that cannot be compressed, that cannot be changing into a shape that makes it occupying smaller volume, I might say. But because most liquids are incompressible, then we say, okay, if it is liquid, then it means it is independent of pressure. But actually, only incompressible liquids. So there is 1% that might depend on the pressure somehow, but 99% of liquids are incompressible, which means they do not depend on pressure and temperature also. But for gas, it is different. It is really sensitive. Density of gases, it is really sensitive. It is really responsive to pressure and temperature. They are strong function of T and P. One more thing to know about density is the fact that it can be related to two components. So I could relate a density of a certain chemical, if it is liquid for example, with water. And if you relate one density with another, then we are talking about specific gravity, which is relating a density of a certain chemical of liquid phase if you are using a relative or a standard density like water, and for liquid. Also, you will hear about specific gravity for gas, but the reference point or the relative density, it will be density of a chemical, which is more likely to be gas if it is relative with density of air. We would expect this specific gravity to change faster with temperature and pressure because it is for gas. But this one, it is hardly changing because it will be liquid over liquid, and we know that liquid or density of liquids are weak function of temperature and pressure. You will see a lot of books that are listing a table of specific gravities, many specific gravities. I actually have never seen a book that lists the specific gravity of a gas, and I can't be surprised because density of gases change, so you can't really fix them on a table. But because the liquid is constant, so that's why maybe they are listing many tables about specific gravities for liquid. It will be really helpful, and they are used also as a conversion factor. Suppose you need to know a density of a certain chemical, just multiply this density of water by this specific gravity that should be given, by the way, to find this density of the chemical, liquid or liquid chemical. So specific gravity works as a conversion factor. By the way, here also, you can use the density as a conversion factor to convert from volume to mass, right? Because mass equal to density multiplied by volume. This density will work as a conversion factor, so that's why we are always saying conversion factor, significant figures, scientific notations, numerical skills. These numerical skills are really essential because we will always see them whenever we are calculating each process variable. And now for the other process variables, I will delay the story of the entropy when we come to the thermodynamics. I will delay the energy when we come to something called really essential called energy balance. and I will keep focusing on mass, volume, density, and whatever is related to them. I'm not gonna rush you or rush myself into the examples immediately. I wanna illustrate or solve the examples with you one by one in another video. And I think that's all I have for now.